Yeah, thanks, Arvind. Um, yeah, clustering means nothing but we are going to group the records based on some characteristics, based on some similar kind of attributes, similar kind of behavior, right? Um, but it is unsupervised. We are here. There is no trained model. Uh, uh, Directly, we are start grouping the records. When you do that, when you start doing such kind of things, it going to group based on the attributes behavior or attributes characteristics. So based on the attribute characteristics, it's going to be group similar kind of records, and it's differ from unsimilar records. Here we can take it as objects, right? Okay. In the graph based clustering, first we look at the application area where actually it is using in the real world environment. So just look at world networks. So biological networks, um, gene regulatory networks, metabolic networks, neural networks, food web, like that, and a technological application of technological environment, telecommunication network, internet, power grid, like that. Um, and a social network, the communication network, organizational network, social media, online communities. So economical networks, financial market, in the economic networks, financial market network, trade network, and collaboration network. So when you look at the application, we can connect one object with another object. Or when you look at the graph, just look at this. We can take it this one or this one, any kind of business. If you want to do an an analytical process of social network, so we are group similar kind of behavior. The user who are using the social media. So the user, how many users are no liking? If in the Facebook, no, it's the multimedia in the area. So how many people are liking politics? How many people are more interested on politics? So how many people are no focusing on financial thing, or how many people are giving much important on entertainment thing, movies, clippings, comedies, all those things. Some memes thing, and sports. So many people are keep on searching or keep on spending time on watching sports, or how many users they are spending much time on politics and memeing, and so this is the thing. We can group the similar kind of user behavior, right? So if you take last 1 week or 1 year or 24 hour, whatever it may be, we can fix some bound threshold, and based on the threshold we can group the records. How many people are more focusing on a particular area. Sports, it may be a post, it may be a politics, it may be a history, it may be it may be what medical news, whatever it may be. So we can group based on the application, based on the user behavior, um, with help of we can represent as a graph, right? If you look at the economic networks, so financial market. So if you take worldwide investment, how many companies are focusing on that different kind of application? They are trying to invest the money in telecommunication area, or pharmacy environment, um, and agriculture field. So any kind of things. If you look at that, so you can analyze the um, analyze the economics based on their investment aspects, and if you establish one company in one particular state, so how many people are now getting job opportunity? So how many there are so many things that we can do we can do analyticals on that data set. Social networks, or some any if you take any if you take any data analytics. So based on the user behavior, based on the not only the user behavior, we can do web analytics, economic analytics. So there is some certain parameters, certain behavior in that application area, right? If you take medical environment, doctor, diseases, behavior of the diseases, treatment of the behavior. If you talk about the agriculture environment, agriculture environment. So what is that, weather forecasting, crops, things, anything if you want to analyze this, we can represent, we can group similar kind of behavior, right? Okay. So here also the clustering, doing the same process, nothing, there is much difference from other clustering techniques. Here they are doing some method of doing is different. The method is identifying the group of similar samples. That means similar objects. Here objects means records. Okay. Okay. With no prior assumptions, because it's unsupervised method now. So that's why there is no prior assumptions. So what are the records is there? We are start analyzing the records who are have similar kind of characteristics. We are grouping according to the field. Okay. Yeah, when you talk about the graph based clustering, so behind the graph based technique, we called as graph theory. So it's a backbone of graph based clustering. It's completely built on graph theory. Okay, graph theory can provide more details information about the inner structure of dataset in the term of. So they are listed in that, no, clicks, clusters, centrality, and outliers. Outliers means, you know that, no, those node is not included with any kind of groups. So like that. So centrality means important nodes. It may be play a vital role. So centrality means it may, if you talk about the sports, so sports is a centrality. Okay. So sports. Then if you have cluster, no, even connected the group of nodes. So even this sports, we can list out so many sports, football, cricket. So there are based on the content, we can cluster the we can group the records. We call it as cluster. Click means it's nothing but it is a subsets of nodes where each pair of elements is connected. Like if you talk about the cricket, those if you take cricket as a cluster, in the cricket cluster, each node, like player aspects, ground aspects, or any kind of terms in the cricket, those connectivity among the. If you talk about this bowler is the any node. Like if you take MS Dhoni as a record, no, so we can do any kind of similar kind of things. If you captain captain aspects or wicket keeper aspects, the batsman aspects, like we can group the records. Are time bound from this time to this time, any kind of things we can do that. So the particular player do the communicate with other cricket player. So within the cluster, the node connected with other nodes. Other node is nothing but another record. So like that. So cluster ends, no, it's talk about the particular area. So like that. So graph theory can provide the more details information about the inner structure of the data set. Okay, application, social network analysis. What are the diffusion of the information, the direction of the informations. If you in the social network, we can take any kind of directions. One user or one he may interested in social entertainment things. So if you take that direction, so what is the favorite movie, how many times he is watching a particular which language is one, what kind of movie is one, a comedy movie or thriller movie, suspense, so it's the direction of the informations. Okay, the user, if you take one link, that link gives so many informations. It's a directions. Okay, if you talk about the entertainment, so what is it? Reality shows, TV shows, or any other interviews, um, any movies or comedies, whatever it's take another directions. If you take one more link, if a movie, what kind of movie, which language, if you regional language, okay, what kind of gender. So anything we can take different kind of that means a diffusion of information, spreading of diseases or rumors, like that, the same thing. So if you take any WhatsApp group or any social media network, no, the if you receive any messages, right? So without our analyzing with this authentication or not, but we start for the people start forwarding to all the peoples. So the it take one link, it's one group to another group, another group forward to another, like that, it no it's the spreading of that informations. So just imagine that. So it's all about that node and connectivity. If you look at the diagram, just look at the diagram. If you look at the diagram, so it is the connectivity of all nodes. So if you look at this, you can see that no, this is a cluster. If you look at this, no, this is the another cluster. So if you see that, no, in the social media environment, when you do some analytical process based on the connect interconnected with the nodes, and interconnect with other cluster. So we can say, or we can predict, or we can group the records according to the user behavior, right? Okay, right. So when we talk about the graph theory, yeah, it's a graph of in the G equal to vertex and edge, right? So a vertex is nothing but nodes, and edge between the link between the two nodes. What is the value or value in the E equal to, we can take into the different thing, weight of the link, or according to the application we can take. So in the graph theory, so G graph equal to vertex, that means nodes, and the value of value between two nodes. So there is one application, that marketing campaign, viral marketing, social network advertising. So those are the applications. If you talk about that graph based clustering, no, so this is the applications based on the graph based clustering. Uh, they are do the analytical process, and they are doing in different kind of fields. It is used to no, we are using the concept. Guys, could you understand my points? Okay, so the topic is, yeah, the graph based clustering, collection of wide range of very popular clustering algorithm that are based on the graph theory. So here the graph theory is the key point. Graph theory is nothing but G equal to vertex and edge. So organize the information in large dataset to facilitate user for fast access of required informations. Okay. Yeah. This idea. So objects are represented as a node in the complete or connected graph. Okay. So just take these two graphs. So in the graph, assign the weight of each node. So for example, this is the node. We can take this is the object. So object is particular record. We can take it like this. So is a so in the objects or have similar kind of behavior. The each node have some distance. That means distance is nothing but there is similarity between each nodes. Okay, so here there is there is a distance between these two cluster. Okay, might be this nodes might be connected with these nodes, any kind of things, no, like that. So we are going to do the analytical process which are more similar kind of things. If you have that density of that records, density of the nodes, we can group as a cluster. Okay, right. Yeah, assign a weight to each branch between the two nodes. If you take x and y, here is the x. If this is the y, right, the weight is defined by the distance between the nodes. Yeah, there is so many distance, no, finding the measurement of two nodes, like that. So we are going to find the distance between x and y. Then we say that, no, if the value is less, we can say that, no, these two record very similar kind of behaviors, the similar kind of profiles, like that. So if you take this distance between these two nodes, if you see that, no, it's a factor away from that this kind of, no, we are saying that, no, so distance between the two classes. Okay, yeah, each and every object each and every object, every node, we are representing as a graph. Just look at that, it's a graph. So it's each red dot says that, no, it's a node. Each blue dot says that, no, it's a nodes. That means records. We are going to break the link. Okay, so we going to create the cluster using some techniques, minimum spanning tree and Prim's algorithm, like that. So just this is the graph. We are going to cluster the records based on the similarity, right? So just look at this. So when you do the calculations, so using minimum spanning tree, so just remove the distance between two nodes. Okay, then we may get this kind of minimum spanning tree. Okay, again we need to find the distance. Like if you take this distance, this one, no, it has some values. When you compare these values with another node which has some link, now if you take these two nodes, definitely it's going to be weight is very large, or that means it's far away from the nearby nodes. So if they are grouping, like each all the nodes are in similar kind of behavior. When you take this, no, they are going to break the link and says that, no, this is different kind of attributes, different kind of behavior. When do the comparison this thing, because we can say that, no, this is the one cluster, because each in the cluster each node have very less weightage and the distance is very low, very small. So those records are we are grouped as a cluster because those cluster have certain characteristics. And then which we are taking the value because it's connected almost, it's also connected, this node is connected, this node is connected. So we are evaluating the distance. If it is taking, no, it's very short. So here it's very near, it's very near. When you take this distance with this one, it seems like that, no, very long. So we break the records, we break the links. Again we break the links. Again we break the links. Why? Because when you do the when you do the distance between these two nodes, no, it is very similar. It, no, if you take this one, no, it's far away from the nearby node. So we are breaking the links using minimum spanning tree. So we can say that, no, this is the cluster, similar kind of behavior, it's a similar kind of behavior. um, yeah, um, determine the minimum spanning tree. We know that minimum spanning tree. So if you yeah, because our objective is to find the distance between uh, two nodes which have very less value, very less distance. We are saying that we are grouping such kind of similar kind of records, similar kind of nodes, and make it as a group. We say it as cluster, right? So now we need to find the distance between each and every node. What is the application minimum spanning tree? If we want to know give the cable connection or telephone connection to all the, if you find the minimum spanning tree, so each node need to be connected, but it should not take circle, right? This is the basic line of minimum spanning tree. Each node should be connected, and it should not be take no loop format or circle format. Okay, so first they are taking like this. If you this node need to be connected, this node need to be connected, this one, a node connected, every node is, are interconnected. But when you look at the distance or values or weightage, okay, so a node need to go, distance between a and b, so its value is 1. So when compared to, if you the vertex b need to no, find the minimum distance between with b, no, this is the if you find a to b, its value is 1. It's another way we can go with d and then find the b. So 3 plus 8 almost 11, so it's not possible. Then we again we another node we need to find the distance. So a to d, right? The each node need to be connected with other. So then a to d, so 3. Otherwise no, a to b and then b to d, so it take 9 values, but it's very so a to b and a to d, right? Then c, if you a directly go to c, no, its value is 6, right? The value is 6. But when a goes to b 1 and b to c, it's 4. So we can choose this way because minimum values. We can break this. We can break the link this way. If a to d, if you this is the link. So d to a 3, r to b 3 plus 1. If the direction, that means the link between d to b, no, if you take directly, it says 8. Weightage value is 8. If you go to a 3, then a to b, it's 1. So only 4. It's half of the values is weightage is less. Okay, like that. So look at this. G equal to graph of vertex and edge. So each x need to connect it, and it should not be low. When you look at this, using minimum spanning tree, so A can make a connection with B, and B can connection with C, and A can connect with D. All the nodes are connected, but it should not take cycle. Okay. Yeah, that is some algorithms. I hope you know this Prim's algorithm and Kruskal algorithm. It's nothing but it is a shortest path algorithm, minimum distance between two nodes. Okay, so based on the concept, we are going to frame the cluster. Yeah. Could you understand this one? All the records, all the objects are represented as a node, and each node connected with other node based on the distance or based on the weightage. Once we need to find the distance between each and every node. It has minimum values we can frame as a group. We call it as cluster. The node have more value or more weightage, or it seems like no distance between two nodes is very high. Then we break the, that means we break the link between two nodes. Okay, like that we are going to delete the branches. So delete the branches with maximum weightage. uh, the criteria is, if you have the maximum weightage, we are going to delete that. Delete inconsistency branch. Yeah, we are going to look at this concept, inconsistent branch, and delete the analysis of weightage. Okay, based on the analysis, we are going to delete the link. It takes some time. Yeah, just look at the diagram. In the diagram, so each nodes are interconnected, right? Um, Each steps create the two new cluster by deleting the branch with maximum weightage. Cluster size is 2. Repeat until the given number of cluster is reached. So they are saying that no, two cluster, two new cluster by deleting the branch. Okay, just do the calculation between and the, we are saying that no, each node represent as an object, that means records. So that similarity between two nodes, we say that no weightage. So two, if you take these two nodes on 2, this, if you take these two nodes 2, if you take these two nodes 4, if you take 3, and if you take this 2, so then we need to calculate the which has more, which two nodes has more weightage value, more maximum weightage. When you order the weightage branch, so 6 is the first one, so 6, and 4 is the next one, and then 3 is, remaining are 2, 2, 2. Okay, so first we need to going to remove the link which has more values. Okay, so from here to here, no, yeah, we are going to break the link between these two. So if you remove this value, automatically it has similar kind of we can say no, this is the some good of, again we can say that no, remaining things are, because k value is 2, cluster value is 2, 2, we can, why we could you understand this one, why they are breaking the links? If if, if you look at the graph, it seems like no, all the nodes are connected with each other, with each nodes have some value, that means weightage value. So if you want to break it into two, we need to find the value weightage which has more weightage between two nodes. Okay, so among this one, these two nodes has more weightage. Okay, then we are removing this one. If you remove this one, we are saying this no, remaining things are one group, and remaining things are one group. Okay, if it is two cluster, what about if the cluster is 3? Okay, next value which is um, next maximum weightage value 6, then 4. If you break this one, automatically it says the cluster group and the cluster and the cluster, because we are saying cluster is 3, right? If you, it's a single graph, we want if you ask cluster k equal to 3 or k equal to 2, how many cluster you want to group a record, we can say based on the weightage value between two nodes, we are ordering order the weightage branch. Then we say that no, 6, uh, if you break the 6, automatically it seems like 2. If you 3, no, if you know, then if you say that no, 4, if k cluster equal to 4, k equal to 4, obviously it's going to be remove that. So we can say that no, this is the cluster 1, So this is the cluster 2, this is the cluster 3, and this is the cluster 4. Okay, so k equal to 4. Okay, so we are saying that no inconsistency. So a branch E is inconsistency if the corresponding weightage is d of 3. They are doing some d of 3 calculations. So d of 3. So 3 2 1 d of 3 1, that means 3 2 1. Calculate down by number of nodes 3. So we say that no, if you satisfied this condition, so 6 greater than 2 equal to d of d3. So it's a inconsistent. So the reference value d of e can be defined by the average weightage of all branches adjacent to e. Okay. So if it is if it is inconsistent, we are saying that no 6 is the maximum value. So we say that no 6 is the inconsistency. Okay. Then this is for exercise to find the minimum distance between each and every node. Just I move forward. Yeah, they find the minimum distance between these two. I told you each and every node should connected, but it should not take close loop, right? So they are finding minimum distance. Minimum distance. Yeah. If you look at this node, yeah, one again all the nodes. It's connected. It's also connected. It's connected. It's connected. All the nodes are connected, but it's not taking the closed loop, right? Okay. When you look at this one, it's not taking the closed loop. Yeah, same thing, no? If you find the k, if you frame that no k equal to 2, what is the value? 6. If you find the values, which is the maximum value? 6, 4, sorry, 5, 4, 3, 2, like that. If which is the maximum weightage? If you break this one, they can say that no cluster equal to 2. Cluster equal to 2, right? Okay. If k equal to 3, cluster equal to 3, which is the maximum value? Okay, we can break this. Right. Which one is this one? So we can say this no. This is the cluster 1. So this is the cluster 2. So this is the cluster, like that. Like that. So if you if it doesn't have any values, we can say that no, this is an IC value because it has only one node. It's a negligible. It's no. We need to ignore that value. So we can say that no, it's an IC value because it has only one value, one records. So in the end of the class, so graph-based clustering objects are represented as a node in a complete or connected graph. Okay, the distance between two objects is given by weight of the corresponding branch. So analytical method determine the minimum spanning tree and delete the branch iteratively and visualize the information in the large data set. Could you understand this one? In the graph-based clustering, so we are represented as a graph based on the graph theory concept. So we are finding the distance between each and every node, which node have maximum value. We are going to break that and frame the cluster. Like that, remove the values between two nodes. Then we are representing as a cluster, right? Could you understand this concept? It's a small one, a very very simple one, and it's completely based on the shortest path concept and graph theory concept. Where graph equal to vertex and on edge concept, and minimum find the minimum distance between each node. That means a minimum spanning tree. Prim's algorithm, digital algorithm, based on this concept, it's they are implementing in the clustering environment to cluster the records, to group the records. Guys, please, if you have any doubts or any queries, please put it in the public chat, or you can turn on your mic also. Please respond in the public chat. Could you understand this concept?
Srinidhi sir want
That's it, sir. Topic